Welcome. This is part one of our study guide. So here we go. First of all, a great thing for your note card is our rules. Zero exponent, anything to the zero power is 1. Negative exponents puts basically that thing under 1. A times b, our exponents in this case are going to add. The power rule, a to b is going to be our exponents multiply. And our quotient rule, when we're dividing, our exponents subtract, and it's the top minus the bottom. Okay, so first one, negative 3 to the 4th power. This is basically just going to be negative 3 times negative 3 times negative 3 times negative 3. Two negatives make a positive 9, and positive 9, 9 times 9 is 81. 5 to the negative 2nd power. First of all, I'll get rid of the negative exponent by putting it under 1. And then 5 squared is 25, so we get 1 over 25. Anything to the 0 power is just 1. And then here, we want to kind of slowly simplify. And so we have 3 over 27, so we can simplify that. 3 goes into 3 once, 3 goes into 27 9 times, that becomes 1 over 9. X to the 0 becomes 1, so 1 times 1 is just 1, so it doesn't change. Y to the negative 9 will go to the bottom, and z to the negative 9, since it's already on the bottom, is actually going to switch up to the top. And so we should have that as our answer. Number 6, again, I would like to simplify the inside first and then utilize the exponents, so parentheses before exponents. The 4 won't reduce, but the x6, x squared will subtract. So it'll end up being x6 minus 2, which should give me x to the 4th, and y to the 9th does not change, but we have the power of 3 on the outside. So this power of 3 has got to distribute to all of my pieces. So 4 to the 3rd power, we'll just write as 4 to the 3rd power. Now a power to a power means I multiply, so 4 to the 3rd power is going to be x to the 4 times 3 power, which is going to give me 12. And this is going to be 9 times 3, which is 27, and then we just have to do 4 to the 3rd power, which is 4 times 4, which is 8 times another 4, which should be 32. Again, you can always check that on your calculator. 4, and then you can hit this little button right here, which will do any power you want. 3, and hit enter. We get 64. Oh, 4 times 4 is not 8. I apologize. 4 times 4 is 16. I knew that. And so we get 64, x to the 12th, y to the 27th. There's a good reason why I double check. Otherwise, I would have wrote the wrong answer down. And then last but not least, we are squaring. So this is negative 5 times negative 5. Remember that negative is included, so when two negatives multiply, we get a positive, so that's going to be 25. Power to power, so that's going to be 7 times 2, which is 14. And this has an exponent of 1, so 1 times 2 is 2. And no longer negative. All right, next page. So here we need to go ahead and apply our power rule before we multiply these out. So this is going to be 2 to the 3rd power, x 4 to the 3rd power, so it's going to multiply to give me 12, and y to the 3rd times the 3rd power, which is going to give me 9. And then 2 to the 3rd power is 2 times 2, which is 4 times 2, which is going to give me 8. So we're going to get 8. And then we're going to multiply. And so we're going to multiply like terms. So here we have 8 times 10. So 8 times 10 is going to give me 80. And then we have x squared times x to the 12th. Now those are multiplying, so we're going to add the exponents. So this is going to be x to the 14th. And then last but not least, y to the 9th, y, that is technically with an exponent of 1, so that's 1 plus 9, which is going to be y to the 10th. Same thing here, I'm just going to multiply the first two, and then I'm going to multiply by the last one. So again, negative 2 times 3 is negative 6. Then we have x squared times x, which is going to give me x to the 3rd. And then we have running out of highlighters. Yeah, y times y to the fourth. That should be y to the fifth, and then no w, so it's just w to the third. And then we have to multiply all that by our last piece, and when we multiply it by our last piece, we just have to do these two. So it should be negative 6, x3, x5, that's going to be x to the 8th. No y, so the y stays the same. And then w3, w3, that's going to add to be w6. There we go. Okay. And simplify. So here we're going to see if we can simplify. I see 25 or 45 over 25. I think 5 goes into both. So I'm going to divide top and bottom by 5. 5 goes into 45, I believe, 9 times, and it goes into 25 5 times. And then we have x to the 5th divided by x to the 3rd, so that's going to subtract to be x to the 2nd, 5 minus 3. This is going to be 8 minus 11, which is going to end up with a negative 3, which means I'll just have to leave it on the bottom. All right, in this next one, we have a negative exponent, but the negative exponent is only on the x. It's not touching the negative 4 because it's not in parentheses. So it's really going to be negative 4 over x to the 3rd, and that's it. Because it's not in parentheses, that negative 3 exponents is only affecting the x in which it's attached to, not the negative 4. All right, let's zoom back out just a tad. We have 3 formulas here. This is our simple interest. This would be our decay or depreciation model. So something is getting less in value. And then our last one is compound interest. So simple interest means I'm usually just talking about yearly interest. A lot of things operate in that realm. But compound interest means we might be doing something more frequently in how we are evaluating the interest and how it affects your principal, which is our starting amount. So let's go through our first one. The value of an alpha Murph is depreciating. So we get 29. That 2,900 is our A. It's our starting value for this. It is depreciating here, so I'm going to be using this middle model of y equals A 1 minus RT. The rate is at 12%, so R is going to be 0.12. I write it as a decimal. And then we use, it even says use exponential decay, and it's valued after 5 years, right there. Okay, so it says find the approximate value of the car. Alpha Murph, I kind of felt like that was going to be and for the price, I don't know any car that costs that much. So there's going to be an e-bike. All right, so we get 2,900, 1 minus 0.12 raised to the 5th. You should be able to put that in your calculator in one fell swoop. So 2,900, parentheses, 1 minus 0.12, parentheses, and then hit that little x to the power button and do 5. And we should get a smaller number since we're depreciating, and we do. We have 1530. 1530.42. This is money we're talking about, so we want to make sure we go to the 2 decimal spot or the 10 hundredths spot. Okay, next we're increasing in value, so I'm thinking it's going to be simple or compound. If it tells me I'm doing it at over time, then it's probably compound. So my A value is going to be 1,499,000. My rate is going to be 0.02, and my T is 11. I don't have how often I'm compounding, so this is probably just simple interest. So y equals A 1 plus R to the T power. So that's going to be a large number right there. 1 plus 0.02 raised to the 11th power. Again, we should be able to plug this all in one nice easy step. 1499000, parentheses 1 plus 0.02, close parentheses raised to the 11th power. Again, my number should be larger. It is. It's now like $1.8 million. So we get 1 863,818, comma, 09 as our dollar amount. Okay. And last but not least, we're putting, Kenya's put 32 in the bank, so that's my starting value, 32,500. Interest is 0.02, like our last one, but this time it's saying compounded monthly. How often does monthly happen in a year? Well, that would be 12. So my N is how often something happens, so that's going to be 12, because there's 12 months in a year. So if it was weekly, we do 52 weeks in a year. Is it 52? Pretty sure. How much money will you be in the account after 5? Is it 52 or 56? I'll have to look at that one. I don't think the weekly's on there. How much money will be in the account after 5 years? So t is equal to 5. So we're going to use our compound interest. Go figure, we used one of each. And we start with 32,500. 1 plus 0.02 over 12. That's how often I'm going to be doing that. And then 12 times 5. Again, just grab your calculator. We should be able to do this all at one step. 32500, parenthesis 1 plus 0.02 divided by 12, parentheses closed, raised up to, and I'm going to put in parentheses 12 times 5, so it doesn't actually do anything funky. It should be more money. It is. It's going up from 32,000 to about 35,000. So our final answer, 35,915 and 0.7 dollars and 7 cents. Okay, moving on. This took a little while. Which graph represents an exponential function? Well, this graph is linear. This graph is quadratic. So this one is exponential. As we move on, it gets bigger and bigger and faster and faster. All right. Which of the following, complete the following table, trinomial, 3 terms like x squared plus 2x plus 2. Polynomial is anything greater than 3 terms. We just usually call it polynomial, but you call it trinomial polynomial. So usually it's 4 plus terms if we're going to be using that. And again, we could do 4x to the 4th plus 3x squared plus 11x minus 2. I don't know. Monomial, 1 term, it can have lots of variables on it, right? But there's no addition or subtraction separating it. So that's just 1 term. And then by monomial, we could just do something like that. That would be a binomial. 2 terms, like a bicycle, bicycle. Given the expression below, underline the first term and circle the constant. So first term, the constant is the number. Oh, whoops, sorry. Just underline the first term, circle the constant in the entire thing, which is 5. That's the only one that's by itself, and put a box around the leading coefficient. I was supposed to put a box around number 2. I'm sorry. So the leading coefficient is the number in the very front. The leading coefficient doesn't include the variable. Coefficient is the number in front of the variable. The constant is the only one that doesn't have a variable. Variable means it varies. Constant means it stays the same. So that 5 will always be a 5. This one will always be a 3 if x is 1 versus if x was 20, this value would change. That's why we call it a variable. All right, classify the given polynomial as monomial, binomial, trinomial, and identify the degree. 1, 2, 3 terms. That's a trinomial. And its highest degree, this is 2 and 2 more, so that's 4. That has a degree of 1, and that has a degree of 2. So it's a trinomial 4th degree. We do typically have names for our degrees for pretty much just 2, which is squared, and 3, which is cubic. Anything else, we usually just say the number of degree. This has 2, 1, and 4. That's a total of 7. It's a monomial and 7th degree, like 7th degree belt, black belt. All right, 19. Write it in standard form. So standard form means I'm putting the largest degree value first, which would be negative 3x squared. And then I'm going to go negative 2x, keep the sign that's in front of it with it, and then plus 10. The leading coefficient is going to be negative 3. The bottom one, my largest exponent, is x to the fourth. Then it's negative 5x squared, then positive 7x, then 15. Leading coefficients right here, it's actually just 1. Number 20, we have these pieces combine the like terms. Well, 5x and x would go with each other, and that would make 6x. 1 and 4 go with each other, and that makes 5. And that, if I'm being honest, has to be the easiest problem on here. Okay. Add. So here we just want to combine like terms. So what we see here, 6x to the fifth and x to the fifth. There's no subtraction. We're just adding it, so that becomes 7x to the fifth. The next biggest exponent is right here. No one to combine with, so we're just going to do plus 5x squared. Then we have positive 8x and negative x, so that's going to be negative 1, positive 8, so that's positive 7x. And then we have, last but not least, 10 and negative 3, which should be a positive 7. For 22, we're subtracting, which means I do have to distribute this negative first. So I should get 5m to the fifth minus m cubed minus m to the fifth minus 7m cubed plus 4. So we do have to make sure we distribute that negative. Now we just combine our like terms. Again, here we go. We got the 5m to the fifth minus 1m to the fifth. That's going to be 4m to the fifth. Okay, next we have negative m to the third and negative 7, which make negative 8m to the third. And then last we just throw on that 4. Now we get to some simple multiplication boxes. That's going to be x times x, which is x squared, and just x, so our answer is x squared plus x. No like terms to combine. Okay, multiplying on this one, we get x times x is x squared, x times 2 is 2x, x times 1 is 1x, and 1 times 2 is 2. Usually our like terms are going to be along this diagonal right here. And so we're going to get x squared, our highest degree first. 2x plus 1x is 3x plus 2. And there's 24. All right, it looks like I'm going to be basically going through this page, and then we're going to be done for this part. So 4x, 3x plus 2. Now, I could write a box for this. I usually distribute these. 4x times 3x, 4 times 3 is 12, and x times x is x squared. 4x plus 2 is just going to be 4 times 2, which is 8. Throw in the x, and you're done. Once I get to the binomial, I switch over to the box. So x minus 1, x minus 5, x times x is x squared, negative 5x, negative 1x, and positive 5. Again, along that diagonal, we're going to be adding. So we get x squared, negative 1, negative 5 is negative 6x, and then plus 5. We've had a lot of practice with these in the last unit, so I might be going a little bit faster. 5x and 4, 2x and minus 3. 5 times 2 is 10, and then x squared. 2 times 4 is 8x. 5 times negative 3 is a negative 15x, and 4 and negative 3 is a negative 12. So we end up with 10x squared. 8 minus 15 is going to give me a negative 7x, and then negative 12. Now, a binomial times a trinomial just means I have to draw a bigger box. That's pretty much it. And then we just do the same thing, just a little bit more combining like terms. So 5x minus 3, x cubed minus 5x, and 2. We'll go ahead and fill that in. That's going to become 5x to the fourth, negative 3x cubed. That's going to be negative 25x squared. That's going to be positive 15x. Negative 3 times 2 is going to give me negative 6, and that's going to be 10x. So actually not a whole lot of combining, to be honest. Looks like these are the only two that are going to combine right there. So we just write them out in order of highest degree. That one, followed by that one, followed by that one. 15 plus 10 is going to be 25x. The x is just there, and negative 6. So there you go. Long term. And x minus 9 squared, just do a square that is x by minus 9 and x by minus 9. And we're going to get x squared, negative 9x, and 81. And negative 9 is going to make a negative 18x, and then plus 81. Alrighty then. And then we have r plus 7, r minus 7. That's going to be r squared, 7r, negative 7r, and negative 49. Now the cool thing is this is going to actually cancel out right here. Oh, you can't see, Mr. Smith. I'm going to have 7r and negative 7r, so those actually are going to cancel out completely, so I'm just left with r squared minus 49, and we call that a difference of perfect squares, because r squared and 49 are perfect squares. And we have one last one. I want to do 31. Find the area of a rectangle if the length equals x minus 8 and the width equals x minus 4. I'm just multiplying these, guys. Come on. So we use the box method. Again, usually when we write it, it looks like a square, but it's actually usually not a square because this length up here is going to be shorter than this length because you're subtracting 8 versus only 4, but you're multiplying. So basically do the same thing we've been doing. Negative 8, negative 4, positive 32. And then we're going to go with combined like terms. X squared minus 12x plus 32. There you go. There's my area. All right. Toodles. Until next time when we finish the rest of the study guide.